Alright, like guys, so let us now jump to lesson number 3. Identifying proportional and non-proportional relationships in tables. So this one is just pretty much easy because you guys have totally understood lesson number 2. Same goes with lesson number 1. So without any further ado, let us now go. But please make sure to subscribe and like the video after you have watched, or probably right now. So it says here, you have been hired by your neighbors to babysit their children on Friday night. You are paid $8 per hour. Complete the table relating to your pay to the number of hours you worked. So it says here, it's $8 per hour. So it means you are going to be paid $8 in 1 hour. So of babysitting. So basically, if you have worked 1 hour, that's going to be 8. If you have worked 2 hours, that's going to be 16. Right? How about 3 hours? 24. 4 hours? 32. Now, how about 4 and 1/2? Basically, for 4 hours is going to be $32, right? And then half of the hour, wherein half of the hour is 30 minutes, so it means you're just going to be paid half of the price of how much they pay you, so that's going to be 4. So 32 plus 4 is going to be 36. Now, how about 5? That is $40. 6 hours is going to be $48, and then for 6.5, point 5 means it's also the half, so it means 48 plus 4 is going to be 52. Okay, based on the table above, is the pay proportional to the hours work? Yes, since the rate is $8 per hour. Okay, next one. The table below represents a relationship of the amount of snowfall in inches in 5 counties to the amount of time in hours of a recent winter storm. So let us identify if y is proportional to x. Now for this one, we have a formula that we're going to use from now on. So k is equal to y over x, where k is the constant rate. All right. Basically, it's like, you're telling me how much is each one of them per unit given. So it means usually the first value, the first table is the x, and then the second value is the y. So let us identify this. So let us find the unit. Our unit will be y, which is the snowfall, so inches per time or per hour. So ratios 10 to 2, 12 to 6, 16 to 8, 5 to 2.5, 14 to 7. So now let us find the k. So what we're going to have is 10 over 2, that's 5, 12 over 6, that's 2, 16 over 8, that's 2, 5 over 2.5, that's 2, 14 over 7, that's 2. So as you can see, all of these are proportional except for this one. So remember this, if at least one, all right, if at least one of the given ratio is not proportional to the constant rate of the other ratios, then it is not proportional. Okay, so always remember that if at least one, it's not going to be proportional. Next, this one. So again, y over x. Okay, so it means our unit is going to be the unit in dollars, or the cost per the x, which is the number of days, so per day. So again, the ratios, sorry, that's 2 to 6, 3 to 9, 8 to 24, and 1, 2, 3. So 2 over 6 is going to be 1/3. 3 over 9 is going to be 1/3 as well. 8 over 24 is going to be 1/3, and 1 over 3 is definitely 1/3. So it means, as you can see, all of these, it means we can say that the cost of renting a movie for $1 is 2-3 days. All right. So we can say there that it is proportional. Okay. So $1 is 2-3 days. That's pretty cheap. All right. Next one. Again, k is equal to y over x. So our unit. All right. Get very good of the way of thinking. Basically, it's going to be cost per pound or dollars per pound, whatever you want to say. So dollar per pound, or you can say per amount of candy, per weight, as long as it's related to what is given, that is fine. So let's have the ratios. So 10 to 5, 8 to 4, 12 to 6, 16 to 8, and 20 to 10. So 10 over 5, 8 over 4, 12 over 6, 16 over 8, and 20 to 10. All of these are equal to 2. So we can say that the cost per pound of candy is, yes, it is proportional. Okay. Last one. Randy is planning to drive from New Jersey to Florida. Every time Randy stops for gas, he records the distance he traveled in miles and the total number of gallons used. Assume that the number of miles driven is proportional. So it means we're going to assume that it's already proportional to the number of gallons consumed in order to complete the table. So let us compute the table. So for me, I would probably say, I want to make sure that it's, I want to make sure that it is proportional. So before that, I need to find the unit first. So usually the first table or the first column, the first row of a given table is the x, and the second one will be the y. So it means y over x will be miles per gallon. Okay. So how do I identify? So since there are only two given ratios, so what we're going to do is to see if they are equivalent. So 54 is to 2 is equal to 216 is to 8. So 2 times 216 is going to be 432. 54 times 8 is going to be, yes, that is 432. So definitely we got this one as proportional. It is correct. So how do we find the miles driven? Basically, you need to multiply it to what? Is it going to be 54? No. Why not 54? Because it says here it's 2 gallons, right? So what we need is miles per gallon. So it means it should only be 1 gallon. So how do we find that? Let's get this one. So 54 over 2. So 54 divided by 2 is 28. So it means, 27. So 27. So it means there is 27 miles driven per gallon. So if there are 4 gallons consumed, how many miles? So what we're going to do is to multiply that. So 27 times 4 is 108. Now, how do we find the gallons? Basically, what we need to do is to divide 189 by the number of miles, which is 27. 189 divided by 27 is going to be 7. 10 gallons consumed will be 270. 12 gallons consumed will be equal to 324. All right. So there you have it. That is how we find proportional relationships given a table. So this one is pretty easy. So I hope that you guys have learned a lot in this particular example. I'll go see you guys on the next video. Thank you.